Okay, your last deliverable is your test plan. Up. Vice is down. Thank you. Your last deliverable is your test plan. Now, as I have said and will say constantly, software quality assurance is the neglected stepchild. Gets the least funding. I mean, how many of you have observed or experienced that testing is what always gets cut or short shrift? Yeah, it's and it's a serious problem, and it's why so much software is buggy. And it's why so much software is late, because there is no focus on quality up front. It's all done later, and because you tend to defer the hard problems, you find all the hard problems showing up when you're trying to ship, and you either push it out there with the hard problem still intact, or you find yourself delayed for 6 months trying to fix them. Now, here's something that's also important. There is one of the great mistakes in the IT industry is confusing software quality assurance with testing. Testing is a very small part of this QA. It's an essential part, but it's a small part. And you can help reduce the testing if you focus on the other aspects. Now, as I mentioned, 20 years ago when I was at Fannie Mae, we had managers there saying, oh, we're doing object-oriented development. We don't need to do quality assurance. We don't need to do testing. And I ended up writing a white paper that basically said, oh no, yes you do. You actually do need to do it, and you need to do a lot of it. And here's how it all fits together. And I came up with a diagram, and this is, I kind of like this because A, I think it's a nice diagram, and B, it pretty much corresponds very well with the move over the last few years with DevOps and continuous and integrated testing. And the idea is that every single deliverable, oops. Oh, I see, I had my slides out of order. Well, I'll go here, then I'll back up. The idea here is whatever you're creating in terms of the deliverable, starting with your requirements, your architecture and design, your PERT and Gantt charts. What feeds into that activity of creating it is whatever methodology you're using, any existing deliverables, which can be either templates or you're simply refining what you already have. Everything goes through an iterative process. Any guidelines or standards. So between the methodology and the guidelines and standards, like here are the deliverables that we have to create. Here is the format to be used. Here is the notation to be used. Expertise. You want people who actually know what they're doing. In other words, if you're creating a PERT or Gantt chart, it helps to have someone who actually has expertise in project management and who knows how to create a useful, meaningful PERT or Gantt chart. If you simply give this to a new hire who has no experience with it and is simply Googling, your quality is going to lag. Key values. What are the key values of your company? Is it time to market? Is it quality of the software? Is it ease of use? So all these things feed into your process activity, and you end up with a new or modified deliverable. Then, with that new or modified deliverable, you have any relevant metrics which need to be automated, objective, and meaningful. You have human reviews, and you have testing, which may be human-based testing, it may be automated testing, it may be both. The result of all these, you evaluate it and say, yes, we're happy with it. No, we're not. Based on that evaluation, you file defects. How many of you have used defect management systems? These are bug tracking systems. This is where you can actually log defects or bugs and say, here's a defect, here's how it shows up, here's how to recreate it, here's its severity and its frequency. And those are two different things, and they have two different meanings. I may have a bug that crashes the whole system, but if it only shows up once a month, I may not care. It may not get a high priority. I may have a bug that simply accidentally replaces a certain letter for another letter, but if it shows up every time that letter is supposed to be written, it has a very high priority. So you have defect feature management simply says, really, defects and features are in effect the same thing on a continuum. You have defects, things that it's doing wrong, and then you start getting into things you wish it would do that it doesn't do, and those are features. And they really are just a continuum, from defects, through minor defects, through minor feature completions, to major features that you want. Configuration release management. How many of you used a configuration management system? I mean, things like Git. I mean, just where you check in code. Okay, and it tracks. It tracks who checked it in. You can roll back. I mean, this is an essential part. I did a case. I testified in a case. It was a failed SAP project. You had developers literally scattered around the world doing both coding and configuration of files for the SAP installation. SAP is an enterprise resource planning software out of Germany. And they had no configuration management. Updates and changes were all being sent around by email from different parts of the globe. There was no way to say, here is a snapshot of what it is as of this date. All you could do was scan through emails and gather files and try to make sure they were actually compatible with each other. Process deliverable improvement is basically based on how we're doing are the things we want to change. This is where a lot of the focus of Accelerate, the book Accelerate, is in, is how to improve your process and deliverables based on your evaluation. And release management is simply your classic alpha, beta, golden master, actual release, quick 0.01 update for all the bugs that we actually didn't mean to release it with, and so on. Years ago when I was writing for Macworld, I attended a private Apple was coming out with a new version of their Mac OS. They're going from 6.x to 7.0 and adding some new features to it and so on. And I had a private one-on-one, this was at Macworld Expo, and I had a private one-on-one demonstration with the project manager for the Macintosh operating system, and showed me all these features and things. It hadn't been released yet, and he said, what do you think about it? And I said, I saw someone with a t-shirt yesterday here at the show that said, I'm waiting for system 7.0.1. How many of you, when an update is pushed out for one of your devices, says, okay, here's iOS 12.0. I'm going to wait for 12.01 or 12.02 or 12.03 before I actually update my iPhone? Yes?
I remember this back when the Xbox 360 first came out. Like the first release would just continuously get Red Ring of Death. And
oh yes, Red Ring of Death.
Yeah. And it would just stop working. You'd have to buy a new one. So we stopped and waited for like a year until they got that bug.
I remember that. And yes, it took them forever to get that cleared up. Yes.
And one of the games I play, whenever they release a large update, every single time they do it, someone finds a game-breaking bug that allows you to just basically win for free, and they have to hotfix it.
Yep.
Every single large update.
Well, No Man's Sky. I like No Man's Sky. Got a lot of hours into it. And they just released their, what was the latest big update? No, it was what it released, and it broke a bunch of stuff. And I set it down and literally have not, and I sit and every now and then I'll bring up Steam and say, okay, what's the latest patch? Oh, we got another patch for it, and we fixed these bugs, and then you go to discussions like, and here's all the things this newest patch broke. Plus, I'm really hacked because they got this thing with power supplies and power cords, and it's like, that's not what I'm trying to do. I'm trying to fly around the universe. I want to manage power cords on base. Yes.
One of my favorite examples of this was I ended up staying on iOS 10. I didn't update to iOS 11 or 12 at all, and then a whole bunch of news releases came out regarding Apple throttling batteries in iOS 11, and then the iOS 12 update had some issues with FaceTiming and how you could like listen in to anybody and whatnot.
FaceTime bug, yes.
And so I was just incredibly grateful that I remained on a stable environment, I guess is the best, or stable release.
Now let's back up a slide because I actually got ahead of myself. Core values in software. And typically, again, testing tends to only focus on this, reliability. System must carry out its functions without causing unexpected errors or having unacceptable downtime. Performance. I keep talking about the cycle on a word processor. You want that 1/10 of a second, no more than 1/10 of a second between when you type and when the letter shows up. Functionality. How many of you have bought as well? I think some of you have already mentioned that you've gotten your hands on a product or system or whatever, and you find that it's not doing critical things you need it to do. It's like, oh yeah, these functions will be there in a later version. Compatibility. Your system must interact effectively with other existing systems. How many of you have got a piece of software and started to use it and said, this should work with this software over here, and you find some inherent incompatibility with it? No problem. I was swearing it at Microsoft Outlook, which I use for my mail client. A few weeks ago, I'm an editor of an anthology of short stories, and I was trying to build an actual mailing list of all the authors of stories that have gotten provisional acceptance. And I tried to create a mailing list within Outlook, within the context section, said, oh, you have to go out and do this, the features. So I went out and did that and said, oh, you have to do this. And I was bouncing back and forth. It would not let me do the two things I wanted to do. and I wrote a post about how much I hate Outlook. Lifespan, we've talked about that. The system must continue to offer acceptable reliability, performance, and functionality over a sufficient period of time to warrant the cost to the client. In other words, what happens if you get a piece of software and you suddenly find out, it's a contact management system, you start to use it, and it says, oh, you can only have 50 contacts. You're like, what? This is useless. And I've typed 50 people in here. I have to go find one that actually I don't know that anyone would release a contact management system limited like that. But you can find software that does things like that. Deployment. You have to be able to deploy the system. And the client has to be able to receive the benefits in a time frame acceptable to the client. You actually have to get the software out there. Support. You must be able to upgrade and repair it over time, and the cost has to be justified. I was doing some source code analysis for a case, and I was looking for tools that would do a couple of things. I found one online that looked like it would do what I wanted, called Understand. Are any of you familiar with Understand? And I said, oh, what is it? And single user license, $1,000 a year. It's like, what? I'm not paying $1,000 a year for this software. There's no justification there for that. So these are all features to keep in mind. So with SQA, we already went through this, the various things, what that means. Types of unit tests. Now, I'm not going to go a lot into this because you're only going to be doing a subset of these, but be aware of the types of testing. Unit class testing. How many of you have done unit testing or class testing? Yeah. That's built into most IDEs, most languages nowadays. It's wonderful. this is actually a relatively recent development, recent for me, over the last 20 years. Cluster testing, and this is just sort of building up. Cluster testing, groups of related units and classes, putting everything together, trying it in a production environment. Performance stress testing, boy, this is something a lot of organizations fail to do. And you have a system, and you've got, you have half a dozen people in the lab pounding on it, and it's like, yeah, it works fine. Let's open it up. Oh, look, we've got 1,000 simultaneous users, and it grinds to a halt. This is a very frequent error in a real-world situation. There are great tools out there that will do load testing, that will simulate large numbers of simultaneous users so you can do it. Yeah.
I personally
Horror
haven't.
stories?
No, not horror story, but rather a question. I personally haven't ever worked on anything where I've run into issues with, I guess, a real world load, breaking something. Yeah, I see examples of it all the time. The Reddit hug of death, right?
Yeah.
And
or actually, the 404 on a website.
Yeah.
Means your back-end server just isn't, or
It's-
actually, what you usually see nowadays is failure to establish database connection, which means you suddenly had a big spike of usage on a website, and it's just not responding time. It's not a software problem; it's usually a hardware problem.
So that was going to be my question: was what sort of things could we be doing wrong that would lead to that sort of problem, and how would we resolve it?
The things that you could be doing wrong, and this was actually, basically, the things you could be doing wrong are when you have a large user base, and you're coming down, and you've got a single box. Basically, at some point, if the users keep growing, the box is gonna have problems. So, what do you want to do? What you want to do is have a load balancer, and then, which will distribute this to multiple boxes, and then you can do 3 types of scaling. The first type is basically horizontal. These are either boxes, individual hardware boxes, or they're individual VMs running on a really serious piece of iron, like an IBM mainframe or something. You can expand the resources here. So you've got this horizontal stuff you can do. You can distribute the workload through here. So you've got a web server, you've got a database server, you've got the actual database engine down here, and you can bump those up. And you can do algorithmic scaling, which is I have some clever scheme to make this work faster. So with load balancing, you're basically, this is what you'll see in industrial level web systems. They'll have a load balancer, which is taking all the requests and serving them out to whoever is least busy here. If you've got some big iron back here, then here we have big iron, meaning an honest to goodness mainframe. And it's very interesting that mainframes were, of course, considered a dying breed, and the web made mainframes a bit valuable again. And mainframes are very valuable for exactly this. Because what you do here is you just have VM, 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 and you spin up VMs, virtual machines, as you need them to parse out the load. And then as you don't need them, you can shut them down. Yes?
So would it be, so basically if I'm understanding what you're saying, generally that sort of thing is if you're handling it all on your own servers, on your own things, then you've got to account for this. Whereas if you're using something like Azure or AWS, they should be taking care of that to some extent.
In theory, they should be taking care of that to some extent, though that doesn't always work. I had a conversation with the manager of a franchise. There's about 1,000 of these franchises. I won't talk about them, who they are, but there's about 1,000 of these franchises across the US. And they have foot traffic that comes in to do things. And they tend to have peak times because of how they're set up as to, every on the hour and on the half hour and so on. And these franchises used to all have dedicated in-house PC servers. And the software that they used to log the customers in and log them out and manage stuff and pay bills and so on was all running local and worked just fine. Well, the corporation decided, we're going to the cloud. And we're going to replace these 1,000 servers in these 1,000 locations with our own cloud-based system. And what happened is that, and this is what the manager is explaining, he says, it's been a disaster. He says, at the top of the hour when we have people coming in, because that's when they usually schedule stuff for us, either at the top of the hour or half past, he says, the system grinds to a halt. Because you have 1,000 franchises all trying to log customers in. He said, we do stuff on paper and pencil. When they come in, we take down their information on paper and pencil. We'll wait till 15 minutes after the hour, and then we go online and update the information. In theory, a cloud, with AWS or Google or Azure or whatever, yes, you should be able to do this indefinitely, spin up VMs indefinitely. It should be invisible to you, but it depends on what kind of agreement you have, what money you're paying, and whether or not everything actually works better. Because cloud-based systems have turned out not always to be quite as reliable as people expect. You hear about a big cloud crash with usually one of the major vendors about once every month or two. Yes?
Yeah. I was going to say, because I know that with one of our systems, we have it set up so it'll spin up a little bit of extra power, basically, if you start getting a large load. Does that basically mean that the corporation just skimped on paying for server per server power on their cloud, whatever cloud server they're using?
I don't know. I don't know if it's commercial. I don't know if they're using someone like AWS or Google or Microsoft, or if they rolled their own cloud or came with some mid-level vendor. It may be that they skimped. And it wouldn't be the first time. Let's get through this because we're going along here. User acceptance testing. Do the users actually like it? And the question is, if it changes things, no, they'll hate it. So you have to make sure it's sufficiently sexy and powerful enough that they're saying, yeah, it's worth learning something new here to do this. Yes?
Example, I use a Mac at work, and the new update changed the default shell to Z shell, and it prints a message like every time. You have to set an environmental variable to turn it off. So annoying.
Why do they do this?
I don't know.
Why do they do this? It frustrates me no end. It's kind of like it's like each time I get a major iOS upgrade on my phone, it's like something changed. It's like, why did you do that? The other way worked just fine. I don't see a big advantage in what you just did. People like to change things. And regression testing. This is where you really want automated testing, which means after every change you make, you run through your full test suite. Because you'll see various figures. The best one is probably about a 15% chance. Anytime you make change to your code, whether it's to fix a bug or to add a feature, you have about a 15% chance of introducing a new bug. Or possibly reawakening an old one. Okay, so your test plans. I don't expect extensive test plans, okay? What I do want to see is that you're checking for reliability, performance, and functionality. Those are things I'm going to ask about. Those are things I'm going to look for. So those would be nice headings on your test plan. Indicate what kind of test you're planning to do. I recognize you may not, in this week, come up with a fully complete test plan because you're still coding. In some cases, you're still designing, and in some cases, you're still writing specifications. So as you do that, it's going to change. For your test, you want to indicate what constitutes success. Again, I'm not looking for something terribly verbose. Some form of user acceptance testing, get feedback, input from the entire team. Now, because there's a lot here, this is a case where you really want to parse it out to the team and say, write the test plan for your portion of the code. Like I said, first draft is due midnight Saturday, but will likely be revised through the rest of the semester. Any questions on that? Sorry, this went a bit longer. So by Saturday, your test plan should be up, your status report should be up. Change the date on your status reports, okay? You should have another podcast logged by then. A bit more reading for next week. But it's all pretty fast. 16 and 17, I think, is the Silver Bullet and Silver Bullet Revisited. So that's going to tie into the Untitled Chapter you should have read this week. Peopleware chapter, don't get scared by chapter 7 through 13. You've been reading Peopleware. It's large print, large margins, and short chapters. That's probably about 20 minutes worth of reading. Accelerate chapter 9, I forget what that's about. Webster chapter 6. And again, my stuff is all very fast. Remember, you've got 4 weeks to your first demo, 5 weeks to midterm. If you have questions, ping me on, roll! I almost forgot to call roll. Everyone is hoping. Because if I fail to call roll, everyone gets a freebie. Okay. Russell, Patrick. I guess thank you. I can stop that. Might be amusing, but no.